All right, looks like we're back. Sorry about that, but we should be good to go right now. Let's go ahead and let's finish up our chat about working with the completing the square method. So we have these two polynomials that we want to solve when they're set equal to 0. Now, when we want to go and solve this, usually we would say, well, let's use the zero product property. But hold on a second. Can this be factored down? Are there any numbers that multiply to give you negative 15, any factors of negative 15 that add to negative 12? Well, hopefully you're saying, actually, no, there aren't. So we used to say that this was a prime polynomial. We would say that it is prime in the integers. That's a terrible boldface Z. But we would say it's prime in the integers because it could not be factored down with integer values. Instead, we're going to have to allow for square root values, or maybe even complex values, things that deal with I. So what we're going to do is, well, we first have to make sure, I should say, that this is in the correct format. And it is. We want the form to be, let me clear some space here. We want the form to be x squared plus bx plus c equaling 0. And that means we want the leading coefficient here to be a 1. So in this problem, if we're identifying the a, b, and the c of the quadratic, a here is 1, b is, my stylus suddenly doesn't want to work, b is negative 12, and c is negative 15. Now, let's go ahead and start solving this. It's in the correct format, and we know what A, B, and C are. What we first want to do is move C to the other side. So I'm going to add 15 over, so it's right here. What I'm now going to do is I want to take the middle value, the B, which is negative 12, and I want to divide it by 2 and square it. That seems a little odd, but let's try to follow along. Negative 12 divided by 2 is 6, and when I square that, I get 36. This number, this 36, is what I want to add to both sides of the equation. So x squared minus 12x plus 36 equaling 15 plus 36. Okay, you might say, why on earth did we do that? Well, if you see in the video, there's a reason for it. The reason is because now this forces us to have a polynomial that can be factored. So what multiplies to give me 36, but it has to give me negative 12? Well, that's just x minus 6 times x minus 6. And then we have 15 and 36. Let's see, 15 and 30 makes 45. 45 plus 6 should be 51. So the idea here of taking the middle term, dividing it by 2, and squaring it is what allows us to create a polynomial that can in fact be factored. I go into a little more discussion in the video. Email me if you want a little more of an in-depth explanation of why that is. So we have x minus 6 squared equaling 51. So how do I solve for x? Well, it's trapped in the exponent, so let's get rid of the exponent. How do we get rid of the squared? Take the square root of both sides. So we end up with x, here I'll move up a step, x minus 6 equals the positive or negative square root of 51. Remember, we could have the positive root 51 or the negative root 51. This is when we're evaluating a number, okay? Let's add 6 to both sides then. So we have 6 plus the square root of 51, or I could have 6 minus the square root of 51. So there's the two possible solutions here. And there's my answer. Now keep in mind, when you solve quadratics, there is in fact two solutions that we're going to have. That actually comes to us from what's called the fundamental theorem of algebra. The fundamental theorem of algebra, I'll give you a really quick abridged definition, says that all polynomials with, I could say even with complex coefficients, have solutions. And in fact, polynomials have the same number of solutions as their degree. So for this polynomial, it's of degree 2, it's going to have 2 solutions. Degree 3 polynomials have 3 solutions, degree 4 polynomials have 4 solutions, etc. Let's keep this practice going with problem number 2. This is 2 from the independent practice. What I'm going to do is I'm going to move the 24 over, so I've added it to both sides. I'm then going to say, take that middle number 2, divide it by 2, and square it. So let's see what we get when we do that. 2 divided by 2 is a 1, and 1 squared is just 1. So that's the number that we want to add to both sides of the equation. So here we just get 25. Okay, this tells us that we can in fact factor down the polynomial. We get an x plus 1 times an x plus 1 equaling 25. So this is the same as x plus 1 squared equaling 25. Well, how do I get at the x value? I have to first undo the exponent. So to get rid of the squared, let's just take the square root of both sides. So we get x plus 1 equals the positive or negative square root of 25. Wait a minute, the square root of 25, that's just 5. So I have x plus 1 equaling either positive 5 or negative 5. Let's subtract 1 from both sides. We have negative 1 plus 5 or negative 1 minus 5. So that means we have, let's see, negative 1 plus 5 is 4, and negative 1 minus 5 is negative 6. Here are our 2 solutions. So in fact, we get real, or I should say, we get integer solutions for this problem. So this problem actually could have been factored down using the zero product property. But we're just showing here that, in fact, the completing the square method will always work as well. Let's take a look at another problem now. This is one a student asked me about. This is problem 2 from the exit ticket. And problem 2 here is going to have a unique solution to it, but not one we haven't come across yet. So let's see, it's in the correct form that we want, so we're good to go there. What we first need to do is move the 5 over. So we have x squared minus 3x equals 5. So I've added 5 over. Now we're going to take the negative 3, we're going to divide it by 2, and we're going to square it. Well, negative 3 divided by 2 is just negative 3 over 2, right? It doesn't simplify. So when I square it, I get 9 over 4. Well, okay, I guess. Let's see, we get x squared minus 3x plus 9 over 4 equaling, well, let's see, what's 5 plus 9 over 4? I'm going to enter that in my calculator and use the fraction feature. I get 29 over 4. Okay, well, I guess that's fine. We're told that the left-hand side should factor down. So what would the factors be? Well, what multiplies to give me 9 over 4, but adds to give me negative 3? Well, take a look here at this 3 over 2, or this negative 3 over 2, this value. That multiplied together to give me 9/4. And what's negative 3 halves times negative 3 halves? Or, I'm sorry, what's negative 3 halves plus negative 3 halves? That's just negative 3. Because that's half of 3, so another one would give me 3. So, in fact, we should have x minus 3 halves times x minus 3 halves again, equaling 29 over 4. Be comfortable working with fractions because oftentimes this is what you're going to have to deal with. They aren't always very nice whole numbers. Quite a bit of the time you're going to deal with fractions, and that's okay, right? Just keep your writing organized, make sure you're identifying step by step, and use your calculator if you need. So what we have here is x minus 3 halves squared equaling 29 over 4. Let's take the square root of both sides. We get x minus 3 halves equals, well, let's see, the square root of 29 over 4. The numerator doesn't simplify. but the denominator does. The square root of 4 is 2. So we have plus or minus the square root of 29 over 2. Let's add the 3 halves over. So we get x equals 3 halves plus or minus the square root of 29 over 2, which we could also say is 3 plus or minus root 29 all over 2. Here are our two solutions. So in this problem, a little more abstract to work with, but not too bad. Just make sure that you're working with the fractions. You're using your calculator and any other method that you can use to really keep your work organized and straightforward so you can see what you're doing. Let's try one more problem. This comes to us from the independent practice, problem number 6. This one, I'd like to take a minute to notice that this one doesn't fit in our standard form. This one has a leading coefficient of 4. It's not a 1. So we would typically say, well, you can't do the completing the square on this. But in fact, we can. We can force that coefficient to in fact become a 1. So we can manipulate this around. Let's divide both sides by 4. I'm allowed to do that. Why not? I can divide both sides by whatever I want. So we get an x squared minus 23 fourths x minus 35 fourths equals 0. Okay? This, I should say, let me try to clear some space here. This polynomial that I just simplified down to is the same thing as the original. Okay? Exact same thing. Just an alternative, simplified, I'm putting that in quotes, simplified version, okay? So let's go ahead and solve this like normal because it's in the form that we want, right? There's a 1 as the leading coefficient now. I don't care that the rest of these are more complicated. I don't care that they're messier fractions. Really, completing the square doesn't care about what b and c are. It just says the first term has to be a 1. And the reason for that is because it comes down to the factoring component. So let's move the 35 over 4 to the other side. So I've added that over. Now let's figure out what the term that we're going to add is. So we have negative 23 over 4. And I have to divide that by 2 and square it. Well, keep in mind, when I'm dividing by 2 here, that's the same thing as multiplying by a half. So negative 23 over 4 is divided by 2 is the same thing as negative 23 over 4 times a half, and I'm squaring that. So this is really negative 23 over 8 squared. Oh boy, let me grab my calculator here and let's see what we get. So negative 23 over 4, that divided by 2 is the same thing as multiplying by a half. And when I square it, I am getting 529 over 64. That's what I get as my b divided by 2 squared. So let's see what we get here. Let's take x squared minus 23 fourths x. And then I'm going to add in the 529. Come on, 529 over 64. And then I'm going to do that to the other side. 35 over 4 plus 529 over 64. Well, you know what? Let me go ahead and combine those. 529 over 64 plus 35 over 4. That is going to get me, oh boy, big number here, 1,089 over 64. Okay, let's go ahead and let's try to factor down this left-hand side here. Now, a lot of people are like, whoa, wait a minute. That's way too complicated to work with. In fact, we actually know how it factors down. We need to find what numbers multiply to get us 529 over 64, but add to get us negative 23 over 4. And people are like, I don't know those multiples, when in fact you actually do. Notice, and I mentioned this in the video, that when you take the middle number and divide it by 2, that is the magic number. That is what adds to give you the middle term and multiplies to give you the last term. So you do know, in fact, what this is going to be. The value that you're going to say is negative 23 over 8. So x minus 23 over 8 and x minus 23 over 8. These two things added together give you negative 23 over 4, and they multiply to give you positive 529 over 64. Go ahead and check it. Check it in your calculator. You'll see that they give you the correct answer here. So this work to the side not only tells us what to add, but it also helps us figure out what the factor will be. So we end up with x minus 23 over 8 squared equaling the 1089 over 64. Let's square root both sides. X minus 23 over 8 equals, let's see, plus or minus the square root of 1089 over 64. Let's figure out what that is. And hey, it reduces down actually quite nicely. The square root of 1089 is actually 33. Go figure. So let's say that's 33 over 8. And then I can add the 23/8 to both sides. So x is going to equal 23 over 8 plus or minus 33 over 8. So we can say that that could also simplify if you wanted to write your answer differently. 23 plus 33. So that could be 56 over 8. And then we could also have, if I did 23 minus 33, we would have negative 10 over 8. And wait a minute, 56 over 8, that's just a 7. So our answers could be represented either by the fraction here. Let me try to write that nicer. We could have these fractions added together and subtracted together, or you could actually go ahead and combine them if you wanted to. Most people would just leave it as that. But our answers would be 7 and negative 10 over 8, which is also like, what, negative 5 over 4? So this is the idea of the completing the square method. Again, you got to be comfortable with the process for this, because once you're comfortable with the process, it doesn't matter how complicated the fractions are. You're just doing that step-by-step procedure, and hopefully you're seeing how in fact it's working when we set this up, how we can actually go and factor it down, all relying on this idea of taking that middle value, dividing it in two, and squaring it. Well, that's all I had for this particular talk. It doesn't seem that I have any questions, so hopefully people are feeling comfortable with this process of completing the square and also this review of section 10.7, the solving radicals. If you're just tuning in, this is the second part of our live stream. We had a little technical issue at first. Go ahead and check the first part out. We did a bit of a review of that section 10.7 solving radicals. Also earlier today for our April 6th live stream in the morning, the AM section, we actually also did a more in-depth review of section 10.7. So if you need more help, go ahead and check there. I believe I did both of the answer key problems from that. And then I also did the first, I did both the exit ticket problems from 10.7 in the morning. And I also did the exit ticket problem number 1 from this exit ticket in the morning as well. So check out those live streams. Otherwise, if you have any questions, please let me know. My email is klinford, that's KLINFORD, at wccnet.edu. Let me know if you have any questions or comments or things you'd like me to go over in future live streams. Otherwise, I'll see you Wednesday. Take care.